Hello boys and girls, welcome to another episode of FoulkesBrau. Today on the bench we have one of these Sinotech flat screen TVs. So let's move the camera over to the bench. We'll take a look and see what it's not doing or what it is doing. Right, so here we have our TV on the bench. I'm just going to plug the power in and what has happened. I don't know if you can see it here on the bottom right. There's a little blue LED that came on, but okay, so there's a standby button. So if I press standby, the LED went off or goes off. And when I press standby again, the LED comes on, so it goes into standby mode, but no backlight. So let's turn the thing around and I'll take the back cover off and we'll have a look inside together. Right, so I've taken the back cover off. I've just put the pedestal back on so that I can stand on the bench. And what you may be able to see, I have it plugged in. It's down there in the bottom left where my pointer is the little blue standby LED. So if I press the standby button, if I can find it, that LED will go off like you see. When I press it on again, and there I see backlight. I'm going to very carefully, very carefully, I'm just going to try and tilt this back without me touching it so you can see the TV is actually switched on. It says no signal. Now that is strange. Like I say, all I've done is I've taken the back board off, and down here I've just disconnected the speakers. That's very strange. I wonder why. What could have caused that? How I could see the backlight came on. You can see the light shining through there, and those holes, all these screw holes. So now I'm wondering if it wasn't some loose connection. Okay, well while we wait, let's go through this power supply. There's really not much to it. Mains, safety capacitors, some MOVs and NTC, and 4 diodes to rectify it, and common mode choke. So once it's rectified, now it's DC, so that'll be about 325 volts sitting there. Then we've got some capacitors in there. If I come round, what are they? Caps on. I don't particularly think they're a very good brand. Okay, you can also clearly see this side here is labeled as the hot side. And you've got some nice separation in there, and they've drawn some nice stuff on the circuit board. Below this transformer is a little opto-isolator, so I suppose it gives feedback into the circuit. I can't really see under these heat sinks. It looks like we've got a switching transistor or FET under here. And then again, filtering, common mode chokes and things like that. What it does look like, I can't see any other wires going into the into the light bay of the TV. I can only see these two, and they look like, you see the tape there, and look, it goes behind this power supply, and I don't see it coming out anyway. It looks like it's actually going into the back of the TV there. It's a pretty simple power supply. There's not much in TVs these days. This looks like our main board. There's one down here, and they've actually built quite a nice plug-in board for all these sound jacks and stuff that plugs into our main board there. So this will do all the signal processing and sound and stuff like that. You've got your inputs down here, your RF, looks like a VGA input, and some HDMI inputs, and it looks like there's even a fiber type port down there. And then we've got a funny little board down, well, two boards, one for indicators status, and the other one is for the push buttons, source, if you want to put it on standby, volume up, volume down, etc, etc. But very interesting. Look how few wires are actually coming to all those push buttons. Actually, very clever way they do it. They use an ADC, and then they each push button that you're pressing will drop the supplied voltage by whatever, and then the ADC will drive some logic. And that, okay, this TV is still going, so I'm going to leave it to run. Not much I can do unless something goes off. So I'm going to let it run for a while, and then yes, we'll come back as soon as something happens. I'll set the camera up and we can do some fault finding. So finally, it's a few days down the line, and finally I've got the fault here. Well, I managed to get the fault permanent, so it's not intermittent anymore. So when I switch the TV on, I can hear the power supply start up, and nothing happens. So what I'm going to do, I'm just going to measure that we're giving voltage to the backlight. Just going to put the multimeter down there so you can see. Is this going to be better? Not really. Okay, it doesn't matter. What I've done is hooked the negative of the multimeter to our negative rail, a negative on the cap. So in the on state, if I measure the output in here to the backlight, I get 24 volts. And if I switch it off, we hear the power supply ramping down. The blue light's on, and we can see our voltage ramping down, 12 volts, 11 volts, etc. We'll switch it on again, straight to 24 volts. Now 24 volts seems a bit low to me for the backlight. There we go. That seems a bit better. 46, 39, 32. That's down to 24. That really seems a bit low to me. I just want to do that again. Switch it off. Okay, we're down to 8. I'll switch it on. 24. And then a few seconds later goes to 86. Right, so it's trying to go high. Obviously it's not seeing something, or something's not happening. So it's not sensing current or something. So I wonder, We'll do that again. Down it comes. Switch it on. 24. A few seconds later up to 90 volts. Even 90 is a bit low. I'm suspecting that the voltage is first too low. It's picked up a fault and it's switching down. We'll switch it off. So what I'm going to do, let's hook it up to the scope. It'll give you a better picture of what, because I don't think you're seeing this very nicely. We'll hook it up to the scope. We'll have a look at it from the scope. Right, so here we have our scope hooked up. I've set it to single shot capture, 50 volts per division, and roughly 1 second per division that way. So I'm going to just put the probe in, and I'm going to switch it on. And there we go. So you see it went up to 24, shot up to almost 100, and it's gradually coming down. Now I was expecting to see, again it's a small TV, but I was expecting to see in the order 220 volt DC. It could be that this one is actually 100 because, like I say, it's a smaller TV. There's less LEDs in it. So I think what I'm going to do first is I'm going to take, let me bring you down and you can see what I'm talking about. What I'm going to do first is probably take the power supply out, because to get to the LEDs is a bit more work. It's easier to take the power supply out and check the return path of this. Normally there's two transistors, one that will switch on, which we know it's switching the voltage through. So the first transistor is switching on. That will go through the LEDs. We've seen this in a previous TV that I've done and I've shown you. It will go through the LEDs. It comes back through two current sense or one current sense resistor, depending how they've split it. It's normally a bigger resistor. It acts as a voltage divider. One leg, the upside of that leg will go to the pulse width modulation control chip to tell it that it's got the right voltage. The downside of that resistor is another transistor or MOSFET that will switch it to ground to complete the circuit. So the first transistor is to put power to the circuit, the switch mode power to the circuit, it's the drive transistor. The second transistor is to pull it to ground to actually enable the circuit. So I want to check both those transistors because I'm actually not expecting to see that. I'll bring you back up. I really am not expecting to see this. I was expecting, let's just bring the position down. And we can make the zoom a bit better for you. So roughly what we can see, it started there after, what is it, we've got it a second division, 1, 2, 3, 4, 5, 6 seconds, roughly 6 seconds. We had the spike and then it gradually came down. I don't expect to see that unless there's a fault somewhere. It could be an LED, I'm more suspect of the power board. I expect to see pulsing. I actually expected to see the pulses if that circuitry was right. So now we need to find the problem. I'm going to start with the power board. It's easier to take out than to take the beveling and stuff off and get the screen out to get to the backlight. So rip out the power supply. We'll measure the transistors on the back and see that they're fine. If they're fine, then we go to the backlight. So let me do that and we'll come back. Right, so here we have the power supply on the bench. As we can see, we've got this little plastic covering on the back, acting as an insulator. It's just got these little white press studs to hold it in. But what we can see up here is a very big black mark, and what we must be very careful of is not to go down the rabbit hole with that. So I'm going to take this off and just fix the focus here. What we can see is here is our LED, over here our little LED power connector, which we measured our 85 volts on, and that will be the MOSFET / transistor that will fire for that. So let's do some checks just to make sure that the MOSFET is not gone and we can isolate it. So is it a LED that's gone or not? So I'm going to switch the multimeter to diode, and all I'm going to do is I'm going to put the positive of my multimeter onto the source pin of the MOSFET. In other words, let's get it like this, that pin down there, and to the drain, and let's see what we get. We get the body diode, so it's not shorted. And of course we can go through all of these MOSFETs like that. Body diode's fine, body diode's fine, and body diode's fine, so there's nothing wrong with our MOSFETs. So now we have to go to the back panel of the LEDs and find which one is open, because what we've seen is the voltage comes in, goes up, and then it switches off. So obviously it's not sensing current somehow, and the chip that would be doing all of that is that little IC down there. I'll have a closer look and see if I can find out what it is, if it's got any markings on it. No, I don't see anything, so what I will do is I will let's see if I can do this with a microscope and tell you what it is. Let's see if I can do that for you. Either way, I don't think it's worth it, because it's going to be some Chinese rubbish that you won't be able to get. In actual fact, it looks like the markings have been taken off. A little bit of spit on the chip, just to clean it. Now I'll have to have a look off camera and see if I can get it for you. But I honestly suspect it's not going to be a chip that you're going to be able to find any data sheet for. Anyway, let's get the panel on. I'll take off the covers and everything. I'll get the panel on, and then we can have a look and find out which LED or how many LEDs have gone for a loop. Right, here we are back. I've taken off everything that goes in front of here. Obviously the diffuser, the white sheet that helps spread the light, and all the covering and the LCD itself. So what is the quickest way to find out what is buggered here? Well, let's see. These strips look identical. If I look at the part number 1420 or and all the other markings 0Y3135DO8 looks like dash ZC 14F-02, made 21st of the 2nd 2014, so it's had a good run, 6 years. They've all got the same marking. So what I'm going to do, I've unplugged here where the LED power strip comes in from the front, and what it looks like is these are all in series. But what I'm going to do for one strip, I'm going to set it 8, 16, 24. Well, let's see. We've got 1, 2, 3, 4, 5, 6, 7, 8. 8 times 3, if we give it 3 volts an LED. And let's limit the current to 20 amps, 20 milliamp. That will give us 24 volts, 20 milliamps. So I can do that easily on my bench power supply. So I'll switch it on. And while it's starting up. So let's see. So that's 24. It's 48. That would make sense. 40, 72. So yeah, 80 volts that we saw, 84 volts. That would make sense. Okay, not a very big backlight. Yeah. So let's see what's going on here. So I'm just going to. Oopsie. Pot. Let's use for something else. So let's set the power supply. We'll regulate it to 24 volts output, and we'll limit it to 20 milliamp. You obviously can't see this, but you'll have to take my word for it. We'll switch the output on. So we've got 2 markings on the board down here, A and K, anode and cathode. A obviously being our positive, K being our negative. So I've just got 2 probes on. So if I take that, let me try and not get in your way, and we'll put the negative on the cathode, positive on the anode, and then we can see that LED bank switches on. We'll do the same here. Dead. And the bottom one. And it switches on. So we've got a dead LED in the middle bank. How are we going to find that? That should be pretty easy. What we can do, same thing, bench power supply. All I'm going to do is I'm going to bring the voltage down to 3 volts. Okay, perfect. So what they've conveniently provided is they've provided these little points here across the LED. So let's do that. Let's see which LED has gone for a loop. It's a bit difficult working around the camera, but so what? So we'll go across this LED here. It lights up fine. We'll move around. We'll come to here. It lights up. It lights up. It lights up. And I think we might be going out of your screen, but anyway, we're checking the last 2. That one lights up. The last one, I don't know how I'm going to measure. Let's see. The last one I don't know how I'm going to measure because it hasn't got a point. So what is suspect, let me just move the camera, is that one, and we'll pan this way. That one, because if I go from here to here, that one lights up. So if I went from here, That should be from the anode. It doesn't light up. And if we went like that, it doesn't light up. If we went like this, okay, that bank doesn't light up like that either. So what I'm going to do, I'm just going to pop off these little diffusers. Let me switch my output off there. They're very easy to take off. Flat screwdriver, you just wedge them up. I'm not going to do it on the camera. I'll just pop them off, and then what we can do is measure directly across those LEDs and see which ones are gone. Right, I've just popped off these little diffusers. You can see, don't throw them away, because what you do, once you've replaced the LED, we can just glue them back on with some super glue. So let's see, are the first two okay? Again, I'm just putting my power supply across it. Yes, it lights up, you can see. Next one. Let me try and get around the camera. There it lights up, you can see that. And we'll pan to the end. And we'll do this one. So there is our problem child. You can see it's not lighting up. Well, you would have seen it go bright if it did light up. Maybe try and get my... Oh, I can't really get out the way. So there is our problem child. One blown LED. So I'll have to measure it and see what size it is, take it out and replace it. And if we replace it, I think our banks should be fine. So let me take it out. The way I do that, I take this strip out here. I think it's glued down. That's what it looks like to me. I don't see any screws holding it down, so yes, I think it's glued down. I'll just slightly wedge it up. Then what I do is I take my hot air gun, I heat it up under the bottom of this at quite a reasonable temperature. You'll see it'll melt, the flux will melt, and I just take it out. It actually basically just floats off. And then what I do to replace it, I don't put any new solder, I just put a little bit of flux, put the new LED on, and I use this solder paste flux, and put the new one on, heat it up, and it sinks right in. So I'm going to do that if I've got an LED for it, and then we will be back and check the strip. Right, we're back on the bench. I've replaced that LED over there, put its cover back, and I've put those two covers back. So let's see if it works. We'll put the bench power supply on. Again, we're going to limit it to 24 volts, 20 milliamp. And our current to 20 milliamp. Put the channel on. I will apply voltage down here. And the whole string lights up. Let's see if you can see the last one. It's not the same color, and it's not as bright, but that shouldn't be a problem as it's only one in the string. So what I will do, I'll reassemble the TV and we will take it from there. Right, here we are. Excuse me, the moment of truth. I've put the TV back together. I haven't put the back cover on. I'm going to just plug it in, sorry for the bumpiness. So let's plug it in together and let's see what happens. I can hear the switch mode power supply starting up. The standby LED came on. Let's put it on. Standby LED went off. And I see a backlight. Yes, there we go. No signal, obviously, to be expected. Let's press the menu. Excellent. I wouldn't know how to change this. Okay, now what happens if I wanted to go to the settings? If I press the volume plus, no, that's not what I'm looking for. Okay, but perfect, it works. So there you go. Don't get led down the rabbit hole with power supplies when it's not power supplies or anything like that. So what we'll do, we'll set up for the finishing shot, and we'll summarize everything that went wrong in this TV. There we have it, boys and girls. Another TV saved from the dumpster. Not a particularly difficult fix. Really, it's in the soldering technique. The fault finding, what can I give you with that? Well, it's relatively simple. If you see, we saw that you're measuring that the power supply is pushing out voltage and it's switching off after a little bit of time, especially if it's pushing out voltage to the LEDs, then you know you have an open LED. What was rather interesting for me is that the voltage to the LEDs is so low, but it's understandable when we saw how little backlight LEDs there. I mean, 3 strips of 8. It's not really that much. Sorry, yeah, three strips of 8, I think it was. Anyway, as always, I hope you found this entertaining. I hope you found it useful. I hope you learned something from it. I'm going to let the TV run now for probably a day or two before I give it back to the owner, just to make sure that everything is fine. One thing that I do advise you guys with these LED TVs is to turn your backlight down if you can. Turn it down until you notice a difference and then go one step back. It will give you years of extra life. Anyway, as always, take care, be safe, and we'll catch you in the next one. Cheers.